I'm going to talk about the standard form and the slope-intercept form of linear equations. I'll assume that you know what a linear equation is and the basics of linear equations. If you don't, I would invite you to watch the necessary videos. So let me start by defining what the standard form is. All right, so if a linear equation has the pattern that I typed out there, then it's in standard form. So it's some number times x plus some number times y equals some other number. Some examples of linear equations in standard form would include 3x plus 2y equals 9, minus 7x minus 5y equals minus 111. Okay? Now, pedantically speaking, the second example contains a difference rather than a sum, but we can always rewrite differences as sums, so that's also considered standard form. Okay? And then if a linear equation is written with respect to this pattern, y equals mx plus b, then it's referred to as being in slope-intercept form. All right, and some examples of linear equations in slope-intercept form include y equals 9x plus 10, y equals negative 4x minus 3. Okay, now it's just tradition why slope-intercept form uses the variables m and b. Okay, there's no more profound reason than that. Now I'd like to talk about the slope, x-intercept, and y-intercept of linear equations written in these forms. Okay, so let's find the corresponding x and y intercepts first. So you may know that the x-intercept occurs where when the y value is 0. So if I replace the y with 0 in the general standard form of the linear equation, I get ax plus 0 equals c. So I can solve for x and I get c over a. So the x-intercept will always be the ratio of c over a, comma 0. Okay, so you can just read that off from an equation in standard form. For the y-intercept, I will set the x value to 0. So solving for y, I get c over b. So the y-intercept is 0, comma c over b. And we can immediately use those 2 points to calculate the slope. The slope will be the difference in the second values of each of the intercepts divided by the difference in the first values. So in other words, c over b minus 0 over 0 minus c over a, and that simplifies to, let's see, so the zeros, we can ignore those, the c's cancel, multiply the top and bottom by minus a, and so I get minus a over b. All right, so we've got there the x-intercept, the y-intercept, and the slope. So if you memorize those, you can immediately get all that information from a linear equation in standard form. Or you could memorize how I derived that information and then just derive it yourself quickly. Okay? Now, let's do the same thing for the slope-intercept form. So, setting y equal to 0, I get 0 equals mx plus b. So, mx equals minus b, so x equals minus b over m. So minus b over m comma 0. There's the x-intercept. So far so good. Now let's find the y-intercept. So setting x equal to 0, well, we immediately can see that setting x equal to 0, we get y equal to b, or y equal to 0 plus b. So the y-intercept is 0 comma b. And let's use those two points to calculate the slope. So b minus 0 over 0 minus negative b over m. So let's see, the double negative on bottom, we can change both of those to a positive, ignore the zeros, multiply top and bottom by let's see, m over b, and so that whole mess simplifies to m. Now, let me tell you something. I personally prefer the slope-intercept form. Why? Notice that it's much easier to determine the slope and the y-intercept. I mean, it's not terribly hard to do it from the standard form, but with respect to the slope-intercept form, notice that you can just read off the coefficient of the x term. In other words, the m. Okay? The m is the slope, so you immediately have it. You don't have to find any ratios. The y-intercept is the number added there on the right side. So you can read that off, okay? And you don't need to calculate any ratios like you do for the standard form. Okay, so that's a very nice form, and you'll find that useful. Okay? So here is an exercise you could do. We can do together. Suppose I wanted to determine the slope of the line that corresponded to this linear equation. All right? Well, that just means I have to read off the coefficient of the x term. So that's minus 17. Okay, done. That's it. Now, what about if I wanted to read off the slope of the linear equation 2x minus 3y equals 12. All right, you could use the pattern for the standard form if you remember it. Now, if you know and love the slope-intercept form like I do, you can convert the standard form into the slope-intercept form. Let me subtract 12 from both sides and add 3y to both sides. Now let me divide everything by 3. Okay, so the slope you can read off is 2/3. All right. So let me have you do a slope calculation. How about 2 of them? Can you please tell me the slope of the line that corresponds to this linear equation? Y equals 4 plus 5x, and also do 6y minus 4x equals 3. Okay, so pause the video and find the slopes with respect to both of those linear equations now. All right, so I will go ahead and do it also. So for the first one, it's in slope-intercept form already. Maybe if you insist on having the x term first, you can just swap the order. And then you just read off the coefficient of the x term, so 5. And then for the second linear equation, we can move the 4x to the other side. And we can divide by 6. So the slope is 2/3. All right. Now, another important skill is to be able to determine a line equation given the slope, to determine a linear equation that corresponds to a certain line if all you know is the slope of the line and a point that the line passes through. So let's discuss those type of problems now. So suppose a line had a slope of 2 and it passed through the point 1, 4. So what is the corresponding linear equation, you ask? Well, we know that if we express the linear equation in slope-intercept form, we know that it would be y equals 2x plus b for some b, right? So we got the coefficient already, that's the slope value, and somehow we need to get the b, right? Since the line passes through 1, 4, I can replace the x with 1 and the y with 4 and solve for b. So let me do that now. So y is 4, x is 1, so b is 4 minus 2, or 2. Putting it all together, y equals 2x plus 2. Okay? Now, a related problem is where you're not given a slope and a point, but rather you're given 2 points. Suppose we needed to find the line equation that corresponded to the line through the points 1, 2 and 3, 4. You can turn this type of problem into a version of the previous type. How? By immediately calculating the slope. So the slope is 4 minus 2 over 3 minus 1, or 1. Okay, so now you have the slope and a point, so just do what you did before. Okay, so y equals 1x plus b, and then pick either point to replace, to get values to replace the x and y variables with. So I'll use the 1, 2. So 2 equals 1 times 1 plus b. So b is equal to 2 minus 1, or 1. Putting it all together, y is equal to x plus 1. All right. So now I would like you to do an example. Would you please calculate or find the linear equation of the line with a slope of minus 2. Calculate the linear equation of the line that corresponds to the line with a slope of minus 2 through the point 0, minus 1. And also find the x and y intercepts as well as make a sketch. Okay, so I want the linear equation I want the x-intercept, I want the y-intercept, and I want a graph. You should be able to find all of that, so this will be good practice. So pause the video and do that now, please. Okay, so the linear equation will be y equals minus 2x plus b for some b. But notice that the given point is the y-intercept. So if you remember what b, the meaning of b, you know that the linear equation is 2x minus 1. Okay, and so the y-intercept is 0, 1, 0, minus 1, so we like that. And then to get the x-intercept, we set y equal to 0 in our linear equation and solve for x. So 0 equals minus 2x minus 1. So moving the 2x to the other side, adding 2x to both sides, in other words, 2x equals minus 1, so x is minus 1/2. All right, so that gives minus 1/2, 0 for the intercept. Okay, and yeah, okay, so now we just have to make the graph. And we already have 2 points, namely the intercepts, so we'll just use those. Give me a minute to finish making my XY coordinate plane. All right, so let's see, 0, minus 1 and minus 1/2, 0. So the line looks something like that. All right. Now I'd like to talk about parallel and perpendicular lines. So let's think about what it means for lines to be parallel. So when lines are parallel, they have the same, they're with respect to the same direction, right? So you can see that that means that they have the same inclination with respect to an XY coordinate plane. So all of that is to say that parallel lines have the same slope. Okay? Let me type that so that there's no misunderstanding. Parallel lines have the same slope. All right? Now, what about perpendicular lines? It'll turn out that the slopes of perpendicular lines are negative reciprocals of each other. So if a line has a slope of 3, for example, the perpendicular line will have a slope of minus 1/3. If you like to know where claims like that come from, let me show you an argument to convince you that that is the correct formula. Give me a minute to make a picture. Almost done. All right, suppose I had a line that went through the origin and through the point B comma A, okay, denoted by that blue dot. So can you see that that line goes through two vertices of the rectangle that I drew there, resting on the x-axis? Now, perpendicular lines make right angles. In other words, they make 90-degree angles. So to find a line, to find the corresponding point to B comma A, what I'd have to do is rotate the rectangle that it's on 90 degrees in either direction. So if I rotated that rectangle resting on the x-axis 90 degrees with respect to the origin, I would arrive at the second rectangle that I drew there. All right? So the point B comma A will end up, after the 90-degree counterclockwise rotation, it'll end up at the point with position minus A comma B. Okay? So those two green lines are perpendicular. Now let's calculate the slopes of those lines. So they both go through the origin. So the slope of one of the lines is A minus 0 over B minus 0, which is A over B. The other one, the slope is B minus 0 over minus A minus 0, which is minus B over A. All right. Notice something about those two slopes. Okay. If you multiply either of those slopes by minus 1 and find its reciprocal, you will turn either slope into the other slope. All right. So this procedure works with will work with any set of parallel or perpendicular lines. All right. So all of that is to say that, let me type this out. Perpendicular lines have slopes that are negative reciprocals of each other. Okay? Another way of saying the same thing is the product of their slopes is minus 1. Okay? Multiply the two slopes that I've put in boxes and convince yourself that the product of those two slopes is minus 1. Okay? Now, let's put this information to use. Okay? Suppose that we needed to find the equation of the line, the linear equation that corresponded to the line parallel to another line with respect to this linear equation. Okay, so I want a line parallel to the line corresponding to this linear equation, but I want the specific parallel line that goes through the point 1 comma minus 3. Okay? So if you like, you can pause the video and try to solve that now. Okay, I'll go ahead and do it as well. So we have a point for the line we're looking for. We can also find the slope-intercept form of with respect to the given linear equation by adding 2x to both sides. So the line we want to be parallel to has a slope of 2, so the line that we're looking for also has a slope of 2. All right, so now we've transform this problem into a version of a previous problem where we were given just a slope and a point. Y equals 2x plus b. So use the 1 comma minus 3. Minus 3 equals 2 times 1 plus b. Subtract 2 from both sides. B is equal to minus 5. So y equals 2x minus 5. Isn't that cool? We found the linear equation corresponding to a specific parallel line that we wanted. All right? Now let's do one more example, this time involving perpendicular lines. I would like you to find the linear equation corresponding to the line perpendicular to another line. Okay, the line with respect to this linear equation, 4x minus y equal to 2. And I want the specific perpendicular line that goes through the point minus 4 comma minus 2. So pause the video and do that now if you can. Okay, so I'll go ahead and do it as well. Let me add y and add 2 to both sides. So I get y, let me add y and subtract 2 from both sides. So that will allow me to turn the original linear equation into slope-intercept form. So y equals 4x minus 2. So the original slope, with respect to the given line equation is 4. So the slope of the perpendicular line, which is what we're looking for, is minus 1/4. Okay? So the linear equation we're looking for is y equals minus 1/4 x plus some constant b. All right, so now let's use the minus 4 comma minus 2. So minus 2 equals minus 1/4 times minus 4 plus b. So minus 2 equals 1 plus b. So b equals minus 2 minus 1 equals minus 3. Putting it all together, y equals minus 1/4 x minus 3. Okay?